Welcome to my project buzzer.com. Now we can going to discuss about the project maximum power angle based maximum power point tracking technique for efficiency optimization of solar PV system. Now we can going to discuss about the abstract of our project. This is one of the maximum power point tracking algorithm process to innovation of the maximum power angle. So we can now discussion of this process. The maximum power angle based maximum power point tracking technique is reported. So the mathematical approach is based on maximum power angle determination is a mechanism uh, adapted of all climatic situations in solar panel on PV and IV characteristics, an angle made up of an intersection of points of open circuit voltage and the short circuit current. So with respect to voltage axis of power point of maximum is determined using the parameters of solar panel modules. The proposed system is implemented as minimize the dependency on variance on voltage and current sensors to reduce the hardware component, also a cost efficient process. So it is very efficient to the maximum power point tracking algorithm for the based on maximum power angle technique. Next we can going to flow diagram of our project. First we can see the solar arrays. The solar arrays are nothing but solar panels, series connector of solar panels. So we inside of solar array we can connect the input of short circuit current and short circuit voltage and the irradiance level, whatever the input of the solar panel. This is solar panels in a very efficient manner to implement it, as we can use the 72 cells of solar panels of 6 panels can use that this block is the solar panel generating the voltage and current. The voltage and current pass through the maximum power point tracking technique. The technique is on to improve our load load uh, load setting and improve our power of the solar panel is gradually increased or gradually efficient manner to improve our process. So we can use the maximum power point tracking algorithm. The tracking algorithm uh, some input signal passed through the PWM pulse width modulation. So pulse width modulation to trigger the pulse on boost converter. The example we can take the solar can generate the power of 100 kilowatts power generating. For example, I will told that we can maximum power point pass through the improve the 120 kilowatts generating the power. After we can pulse with modulation we can use the PWM. So instead of we can use the boost converter is an improve also the power. We can generating of 120 kilowatt power generation of maximum power point tracking. We can also increase the power of 140 or 160 we can range to improve the boost converter. So we can load demand is a response to manner. So very huge demand we can demand response to complete the solar arrays and the solar panels, whatever we can use this very efficient manner is not but that this application process we can also any application to use that this process is one of the solar power generation technique also. Next we can going to discuss about the running process of our project. The proposed system implementation done in MATLAB version 2013a. First to open the MATLAB file window and create a new model file, and after creating elements as per the circuit diagram, the output waveform will be corresponding scopes are connected in the circuit diagram. I will show the circuit diagram of the project. This is another circuit diagram of the process. Next it goes to the results of the project. So we can see the PV characteristics of the solar panel. This is an PV characteristics, y axis and power, x axis and voltage. So we can see the IV characteristics. This is an IV characteristics of the our process. Y axis and current, x axis and voltage. So is gradually decrease. Is an perfect waves for that. Next we can see the solar no. So we can see the solar voltage. This is an solar voltage. For starting solar voltage is initializing 45 voltage is and maximum power of the solar. Next we can see the solar current. This is an solar current. is gradually after it will decrease. So voltage is remain constant, so current will is also remains decreased. Next you can see the power. This is an power of solar panel, something to 250 below amplitude range in solar power is actually gradually to decrease the power. Next you can see about the VDC. The VDC is an um, you can see the boost converter, so we can improve the voltage. It's an 350 amplitude range as processed, so it's an purely DC wave. This next we can see the load voltage. This is load voltage consumer. You can use the resistive load of the load. This is resistive voltage, load voltage. We can use the resistive load as per that process. Next we can see about the load current. This is load current. So see the difference of load current and load voltage is on different amplitude range, but the waves also similar that is on 350 something amplitude range, is on 35 something amplitude range, is on to load consumed voltage and current also.